Alright, so today and all of this week, what we're going to do is something called optimization. This is in section 3.7 of your book. And like I said, we're going to do this all week long. I'm going to just do the one lesson, and then I'm going to give you a longer assignment. It is word problems, so get started on this early. Don't put it off until Friday. But the good news is, secretly, I know that all of you, except for maybe two of you, the two who weren't here last year, all the rest of you should have done some optimization problems before. And in fact, if you had me, you maybe even had me pull out my calculus books and like put this book in your face and say, look right here. You're going to do this again in calculus. So what you guys did before, and for the two of you who weren't here, don't worry, you're really not going to be far behind. I think you'll catch on really quick to this. Let's say that I have a sheet of paper and I want to use it to make an open box. In other words, a box without a lid. Kind of like a shoe box, but not necessarily that big, not necessarily those proportions. And I want to make as big a box as I possibly can. I want to be able to put all my bedazzling beads in it. So if you don't know what bedazzling beads are, right here. Let's say I'm gonna like do my jeans just like this, and so I've been collecting the beads, but they're small, they get everywhere. I need a place to store them, and something like this over here is just too practical. I want to make a box out of the paper that I have, because that's all I have in the house, let's say. So I'm looking for a maximum volume. Now, before, for those of you who have done this problem before, you might remember that what we did was we gave you a sheet of paper and we told you to cut out the corners. And when you cut out the corners, and these now disappear, so you're left with kind of this cross-looking thing. So our piece of paper now looks something like this. And then if you fold it here and here and here and tape up the sides, we end up getting this box here. What we did before, and again, I know that with the Math 3 students, I went through this problem in two different CPM lessons. We did it slightly different each time. But what we did the first time was we took our sheet of paper and we cut out different size boxes. And so let's say like we cut out just this small little box here. We end up then with a very shallow box, but a very wide box. Or maybe, I'm not being consistent with my colors at all, sorry about that. Maybe we cut out something that's large, and these squares that we cut out do have to be exactly the same size, otherwise we don't get the same height on our flaps, which we very much need. Which, if I do that, then I'm going to get a much skinnier box, but it's going to be much taller. So even if you haven't done this example before, I think that this is something that you should be familiar enough with boxes and paper and whatnot that hopefully you can follow along with what I'm doing. So obviously these have their own volumes. You're not going to get the same volume out of every box that you create. And just as a reminder, the volume of a box is length times width times height. Now what we did last year, or for honors, you might have done this for the first time in Math 2 honors. I'm not remembering where it is in the Math honors curriculum. But what we want to do is right now you have 3 letters in your equation. But usually we like to have 1 letter inside our equation. Just stuff with X's. And then other blah, 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 blah. But we want X to be the only letter, the only variable. So what we did, and you might remember this, is we said, well, let's call X the length we cut out. Or maybe here it'd be the length we cut out here. Does that sound familiar to those of you that did this one last year? Now when you do this, by definition, that X length here is going to be the same length as this flap here, and that flap there is the height of your box. So therefore, in our length, width, and height, we could say very easily that your height is the X value. Does that make sense? If this X here is cut out, whatever that X is that you cut out, that's going to be the height of your box. What I love about this is that already gets rid of one of the letters that I have. So already here, I now have volume equals length times width times X, because my height and X are going to be the same thing. Whatever I cut out, that's going to be the height of the box with the way I'm fashioning this. But I do have an issue. I still have 2 more letters. I want to get rid of them. So you might remember, for those of you, again, that did this last year, let's say that I have a computer sheet of paper. And a computer sheet of paper would be 8.5 inches by 11 inches. I know it doesn't look to scale. Nothing I'm going to draw. I will never promise anything's to scale. But let's say that it's going to be this computer-sized sheet of paper. And do you remember, this means here that this length of this flap here, just from here to here, that is going to be the same as this length here. And the same sort of idea here to here will be the width of my box. And we want to find a way to take the small l and the small w and get rid of them. So what we had you do last year, if you remember, if I have a length that is 8.5 inches long, but I cut something off here and I cut something off here. Do you remember here, if I want to find this length, that this must be that total length you started with minus both of the pieces you cut off? Subtraction is the same thing as cutting. Cutting is subtraction. This right here is fantastic. This is going to help me so much. The worst part about these problems is going to be making the equation that you're going to do the calculus to. The calculus itself is going to be so easy, but doing the math to get the equation to be able to do the calculus is going to be the worst part, which is why I'm going to do several examples for you today. So I now have a way to get rid of my L and write it in terms of something with X. Likewise, I can do the same thing for my 11 inches. I cut off an X and I cut off an X. Therefore, this piece in the middle that I'm left with, I should put this is this whole length. This width is going to be 11 minus 2x. I now have an equation for my volume that's in terms of x. It can be in terms of any letter you want, but you want it to be in terms of one letter, not 3, because things like Desmos prefer to have one variable. If I were to type in v equals length times width times height, Desmos doesn't know what to do with that. So here we have our equation, and what we're going to do is we are going to find our maximum volume, and let me just copy this very sloppily here. We have an equation that looks something, let's use a different color, looks something like this. And it does go down like that. So what we're going to do here, this x, remember, x was the length cut for each corner square. If you know what your variables are defined as, that will make the problem easier. And then your y here is your volume. And it should be obvious that if I'm looking for a max volume, right there, And if you can use a graphing calculator, then yes, you would be done. But of course, for your homework, I'm going to say do not use a graphing calculator, or at least only use it to check yourself, because on problems like on the AP test, you will have most of your problems are going to be on a non-calculator portion of the test, and some of these will be on that section. Now, with the numbers I chose, they're going to be complicated enough. I'm going to use a calculator for some of the calculations, but I'm not going to use the graphing portion of it, except for to check my answer at the end. But there we have the location of the max volume, and I know that we've had a couple of weeks to forget everything we've done with the break, but just as a reminder, maximums are extremas, and extremas are the locations where your derivative is equal to 0. So what I'm going to do is I'm going to take the derivative of my equation, I'm going to set it equal to 0, and I'm going to use it to solve for x, so that I know that this x value is going to be the optimum length cut for a max volume. All right, so first things first. Well, okay, this point is probably third things third, but what I see here is I personally don't want to take the derivative of this yet. We can do a product rule with 3 things, but it gets sloppy and it's just going to be worse on the algebra later. Let's go ahead and bite the bullet, take care of the messy algebra now, and it'll make the calculus later easier later. So what I'm going to do is I'm going to go ahead and distribute. Let's bring it over here. Let's go ahead and take care of those 2 binomials first. So we have 8.5 minus 2x, 11 minus 2x, and this is where I'm totally going to cheat with the calculator, because I can do equations until the cows come home, but my weakness is numbers. All right, 93.5. And then minus 22x. Let's see, this would be minus 17x and plus 4x squared. So this means that when I multiply just these 2 pieces together, I'm going to put the leading coefficient, make sure it's the thing with my x squared first. And then let's see, that's going to be minus 39x plus 93.5. And I still have this x outside. If we neglect it, we're changing the problem and we don't want to do that. But what's really handy is this distribution is super easy at this point. And we get just a simple polynomial that's going to be so easy to take the derivative of. Alright, so taking my derivative, I get 12x squared minus, let's see, that would be 78x plus 93.5. And on this point, we want to solve for x after we set it equal to 0. If you remember correctly, or if you remember, I should say, if you have ax squared plus bx plus c equals 0, and remember it does have to equal 0, you can use the quadratic formula, which I won't torture you with the song, but for those of you that had me in class, please feel free to torture your classmates in your study groups with the song. If you had another teacher for class, like Jensen, I would hope, especially, I could see him torturing you with it. And if you forget it, rest assured, I will pull out the song and play it again and again and again and again. All right, so minus a negative 78 plus or minus the square root of negative 78 squared minus 4 times a times c all over 2a. And again, I'm going to cheat here. I'm going to use a calculator. If this was on the non-portion calculator part of the test, they wouldn't give you numbers this hard. Let's see, we're going to have, I'm just going to go ahead and take care of that 7, let's go ahead and get a fraction bar in there. Okay. So I've got 78. I'm going to do the plus first. I'll come back to the minus. Square root of 78 squared minus 4 times 12 times 93.5 all over 2 times 12. Okay, 4.915 I'll say. X equals 4.915, roughly, because it is an irrational number. And let's do it again for the minus. Once you have it in the Desmos once, it's really easy. So 1.585, and again this would be in inches, because remember that's the length you cut out. And if I compare this, I left up my graph on purpose. If we compare this to the extrema on my equation, you see x equals 1.585 and x equals 4.915, which just what I've got down here. Now again, yes, you could bypass so much work on the calculus and the algebra and whatnot if you could jump to the graph. But please, please, please don't do that. Use the graph just to check your work, because you later are going to be expected to do this without a calculator with some easier numbers than these. All right, so let's talk about what we have here with our numbers before we move on. I want to go back up here to the graph that I drew. And I want to talk about the numbers I see, because there actually is an issue we need to discuss. Let's just copy and paste and wait. There we go. So we have some things happening here that we need to discuss, because it's not enough on these problems to get your numbers and call it good. Now yes, you can see very obviously one of your extrema does not work. If we didn't have the graphing calculator, all you would know is that we have these two x's that were given to us, x1 and x2, where this one was 1.585, this one was 4.9 something. I don't remember what it is right now. I want to discuss especially this one. Remember, your y value is your volume. Now, besides the fact that it's giving you a minimum, not a maximum, I want you to ignore that fact for a moment. What's the other issue that you see here? If your y value is volume, what does that say about the volume at this x? Can that exist? Where would I put my bedazzling beads if I have a negative volume? My bedazzling beads are not in negative space. They are in positive space. I cannot put them into a negative space of volume. So practicality will dictate that you are going to need to ignore some of your answers. In fact, you can ignore everything that comes after this point right here. Because that point, if I go to my graph, that happens at 4.25. And I want you to think for a second. If we have a sheet of paper that is 8.5 by 11, what is significant about the point 4.25? If I cut out 4.25 here, and 4.25 here, what's 4.25 plus 4.25? You don't have any paper left. You're not going to get a box out of that. So not only on these problems are you going to get some answers that you're going to you're going to get some answers that are going to seem very reasonable, but you're actually going to need to then go back and say, well, none of these things make sense, because after I hit the point 4.25, I've now run out of paper. I can't make a box out of that anymore. Something that's going to be really important to keep in mind is your equations will make it seem like things will work, but you're going to have to go back and double check your work and think about if they really do make sense. So I'm going to do several more videos with some more problems for you. I'll separate these videos out so you don't get one super long video. You can watch them according to the problems that you want or need. And of course, the problems that you have in the homework, I'm not going to do a problem that looks like every single thing that you do. You are going to be expected to do some reasoning on your own for many of the problems there. But please, 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 lean on each other. Focus on your study groups. Your hardest part on these is always going to be just making the equation. Once you get the equation together, then the next worst thing is going to be the algebra. The easiest part will be the calculus.